Hello student, in this lecture I will discuss the condition of a triangle to be equilateral. If a triangle with coordinate like z1, z2 and z3 are given, like if it is a triangle with coordinate z1, z2 and z3, then what should be the condition or some equation or some identity with this coordinate with z1, z2 and z3, and if this coordinate satisfied this equation, then this triangle with this coordinate must be a equilateral, and that condition we want to find. So since this is the point in the complex plane like z1, z2 and z3, so we can consider the what is the vector corresponding to this point z2 and z3. Like z2 to z3 to z2, we can corresponding to a vector like z2 to z2 minus z3. The vector corresponding to z2 to z1 is nothing but z1 minus z3, and the vector corresponding to z1 to z3 is nothing but z3 minus z1. And if we add these two all vector like z2 minus z3 plus z1 minus z3 plus z3 minus z1, then we can easily found that here it is it is nothing but z3, it should be z2. Okay, z2. So here z3 minus z3 plus z3 plus z1 minus z1 and plus z2 minus z2 cancel out, and this gives is equals to 0. Okay, and this condition is satisfied by any triangle with coordinate z1, z2 and z3, and this condition should not be necessarily be okay. If this condition is satisfied, then it is not necessary that the triangle would be a equilateral, because this equation is satisfied by the every triangle with coordinate z1, z2 and z3. But okay, if we move further steps, and that will only applicable for the equilateral, and that I want to show. Okay, since this is a vector, and if we take a complex vector, and if we take a conjugate of both sides like z2 minus z3 plus z1 minus z2 plus z3 minus z1 is equals to 0, take both side conjugate like this and this. So for conjugate there is a split with every plus or every bracket sign, like z2 minus z3 conjugate of z2 minus z3 plus conjugate of z1 minus z2 plus conjugate of z3 minus z1, and conjugate of 0 is nothing but 0. Okay, so now I will show a one step that is exclusively for the equilateral triangle. And what is the speciality of equilateral triangle is, and it is nothing but the side of the equilateral triangle is all same. So nothing, so we can write that z1. So what the speciality about equilateral triangle is that the side like or the magnitude or modulus of this vector like z2 minus z3 is equals to z1 minus z2 is equals to z3 minus z1. Okay, and if we square this all side like z2 minus z3 square is equals to z1 minus z2 square is equals to z3 minus z1 square, and you know that what is the modulus of z square is equals to, that is the this point complex point into its conjugate. So we can write that Z2 minus Z3 into Z2 bar minus Z3 bar is equals to Z1 minus Z2 into Z1 bar minus Z2 bar is equals to Z3 minus Z1 Z3 bar minus Z1 bar. Okay, so here we have that conjugate of Z2 minus Z3 plus conjugate of Z1 minus Z2 plus conjugate of Z3 minus Z1 is equals to 0. So what we can replace, and we can take this a common value, take lambda. So we can replace, okay, this is the one note for this calculation. So we can write this, or you can take this. So it is nothing but lambda by Z2 minus Z3 plus lambda by Z1 minus Z2 plus lambda by Z3 minus Z1 is equals to 0. So taking lambda also and cancelling it from this side, we can get 1 by Z2 minus Z3 plus 1 by Z1 minus Z2 plus 1 by Z3 minus Z1 is equals to 0. Okay, and this is the condition which is only satisfied by a equilateral triangle, and that is because all three sides of the triangle is equal. That's why this type of identity or equation comes out. And even if you simplify this equation, you get a very simplified version of this equation, like Z1 square plus Z2 square plus Z3 square is equals to Z1 Z2 plus Z2 Z3 plus Z3 into Z1. Okay, this is a very beautiful and very simplified form of a coordinate relation of equilateral triangle. If we have a triangle with coordinate Z1, Z2 and Z3, and if this three coordinates satisfy this equation, like square of 1 plus square of 2 plus square of 3 is equals to the corresponding term product, okay, like Z1 Z2 plus Z2 Z3 plus Z3 and Z1 is equals to, and this both term is equals to equal, then this triangle must be a equilateral triangle. Okay, and this is the condition for a triangle to be equilateral triangle. Thank you.